Hi everyone, and welcome to my final presentation for IST 402, the social analysis of dark networks. For this class, I chose to analyze the Project Togo dataset. Project Togo started in February of 1998 in Toronto, Canada, and lasted for 1 year. It all started when one of the participants in the crime ring told the police that he was a part of an operation that was stealing vehicles and reselling them. They were mainly reselling these vehicles to foreign countries. After this occurrence, the police began the wiretapping investigation, and that is where the dataset comes into play. The Project Togo dataset is a single-node dataset that consists of 33 nodes, each node representing a different unidentified criminal. Each link within the dataset represents a criminal communicating with one another. For this final project, I conducted the research question: how should the Toronto Police use the data that they have collected from wiretapping to continue their investigation? In this dataset, there are 5 nodes that have the highest level of communication with other nodes. These are criminals 1, 2, 3, 6, and 29. I believe these 5 criminals are to be the prospective crime ring leaders. All of the nodes who do not communicate with these 5 prospective ringleaders communicate with 2 other nodes. I believe these 2 nodes are the middlemen receiving information from the criminals higher up and communicating it with the smaller criminals within the crime ring. To highlight the 5 potential ringleaders and 2 middlemen, I have created 2 structural layouts using Gephi to show everyone. I chose to create my graphs for this presentation using Gephi because I believe they are more visually appealing and easier for the user to understand. This is what the Project Togo dataset looks like when it is uploaded to Gephi before creating any graphs. As you can see, it is very confusing to analyze. The first visual I created is the Furcherman-Ringgold graph. Each time I ran this graph with Gephi, the nodes appeared to be in a different place, but still linked with the same nodes. This graph is also easy for anyone to analyze which nodes are connected and how many times they are connected with another node. I have highlighted the 7 main criminals within the dataset and whom they interact with in 7 colors. As you can see, the blue and red nodes have the highest amount of nodes interacting with them. The second visual I created was the Force Atlas graph. This graph is a little bit harder for an outside viewer to analyze, but again I highlighted the main criminals within the dataset with 7 colors. This graph clumps nodes that have communicated together. As you can see, the blue and red nodes appear to have larger clumps than the others. Here's a map that shows the different volumes of stolen vehicles within Toronto. Each neighborhood is ranked with the color, with the darker colors having higher volumes of stolen vehicles. This map shows more than just the vehicles stolen within the Project Togo operation. After analyzing this dataset and visuals, I believe that the Toronto Police have enough information to continue their investigation and start interrogating criminals from this crime ring. I think the Toronto Police should start off with the smaller criminals within the crime ring. These criminals will be more likely to give up information about who they are working with, especially if the officers negotiate with them for a less severe sentence or no sentence at all. As the investigation would continue after that, they should be able to uncover the names of the middlemen, with the hopes of these middlemen leading the police to the crime ring leaders. This concludes my final voice thread. Thank you for listening.